Okay, so this is going to be a session where I talk about programming with Python for beginners. We're going to be using a software known as the Mu editor. There is a online GBD editor as well. So either way, it's a free download, or you can just do play along online essentially. Um, we're going to be covering 3 units. This session is just going to cover the first one, and we might kind of go off into the second one slightly. But each unit is going to have these keywords that you should try and keep in mind. So for my lesson, I would normally recommend writing down these keywords in a separate document, like a notepad or Google Docs, and then just to have them to one side ready to refer back to as and when needed. It tends to be that focusing on the programming side of things can be a little bit tricky when you're still trying to learn the terminology. So having that terminology written down means that if you do get lost, you don't need to focus on remembering it. You can just refer to your little key, and it just allows you to focus more on the actual computational side of things. So I'm not going to go through all of these right now. This is more a case of write it down and then we'll come back to it when it's appropriate. The first thing I want to talk about is the Mu editor itself. It's got several components, or several dozen components, but there's only 3 that you really need to know once you're a beginner. And again, I've got the link at the bottom, which is www.onlinegpd.com, online_python_compiler. So if you don't have the Mu editor, you can use that instead. So what you can access here is, first, we want to talk about the Mu editor is the software we're using, and we're referring to the user interface, how you are going to interact with that software. You need to be aware of the editor window. This is the component where you're going to actually write your code. You need to know about the console. This is where your solution will output. So once you've written the code, what it does will have to appear somewhere, and that's usually in the console window. And then finally, there's actually the run button. It is pretty straightforward, but nothing will happen unless you press it, and then you're going to need to stop after you're done, or when you want to try something new. A lot of the times you'll be surprised how many people will look at their screen without realizing nothing's happening because they didn't hit run, or when they try to run, they actually end up stopping it because they didn't stop it when they were done the previous attempt. So with that in mind, what I'm going to do is I'm actually going to come out of my slides, and I'm just going to demonstrate the Mu software itself. So it's good to know what it is and where to find it. My students will typically have it on their computers, in which you can just type it in, MU, and it will load up pretty quickly. I have got a code I made earlier, but for the sake of this demonstration, I'm going to do one from scratch. Keep in mind, it's probably my best interest to just have this over here. All right. First thing I'm going to mention that's not particularly important, because we will come back to it, is when you're writing code, you will get you will see this hash mark. In Python, this refers to a comment. Whenever the program sees this icon, it will ignore the immediate text that comes after it. That means that this is essentially invisible to the computer. These are very useful when you're learning, but also for when you're just trying, once your projects start to get larger, having little notes about what things are doing comes in handy. So you will see me do that a little bit as we proceed. If we want to do programming, the first thing that we want to just get used to is having text appear on the screen. So we always refer to this as the Hello World program, where we're just going to have a phrase such as Hello World, and we're going to get that to appear for the user. So as the program, I have to type my code, and we're going to use something called a subprogram. Subprograms are essentially pre-built bits of code that will do a series of tasks for you. In the old days, as programmers, you would have to code every single individual action that you want to take place. However, most modern programs understand that there are certain things that all programmers are going to need on a regular basis, so they create these subprograms that you can just immediately access. The print subprogram will, as you might guess, print information to the screen. We can identify subprogram by the open-close brackets, which lets the computer know we are trying to call the subprogram from its internal memory. What we're calling, or what we want it to do, we refer to as we put inside the brackets, and we refer to those as your arguments. So here I can literally say arguments. Now, there are different types of arguments and different types of things that we can put in there. For now, I'm just demonstrating one example. That's not what we wanted, however. We wanted to do hello world. And what we're doing is we're going to print what we call a string. A string refers to literally just text, or not text, but so much as characters and numbers in a sequence. Think of them as words, and we have to be careful because when we talk about numbers, we can talk about numbers as their value, and we can talk about numbers as the word. So if you want to do a string, it's the number, the word. It doesn't hold any value in that regard. But we'll come back to that a little later. Like I said before, if you hit run, you will need to save your project. So I'm just going to call this example online. And then you'll see here at the bottom is our console, and it outputs what I've said to print. So arguments was the first one, and then hello world was the second. Another thing to keep in mind is even though we normally start with hello world, I find using phrases that refer to what it is helps the learner to keep up with what we're doing. So for example, we call a subprogram using brackets, and then we're like showing those brackets here. And there's also, sorry, my keyboard is a little bit weird here. And because it's inside the speech marks, whatever I put here is going to be treated exactly as I'm writing it. So it's going to appear exactly as a string, and it won't try and do something like call a second time, for example. And then here I'll just say this is where we put arguments. And again, I'm actually going to put the brackets because that way when it runs, so again, I have to stop it first and then hit run, you'll see that it shows brackets. This is where we put arguments. And then here it says we call a subprogram using brackets. That would make more sense if I put it the other way around, if we're being honest. And I can even go further and put print here. As long as it's inside the speech marks, we know that it will run, it will just print exactly what I've put. The next subprogram that is good to introduce right from the beginning is input. So if you imagine that print is used to print information to the screen or display information, input does the opposite. It is used for making the user give us information in return. So in this case, I'm not asking for anything, I'm not doing anything other than putting input. This is useful because if you saw the first time, my first message was printed immediately and my second message was printed immediately. So now I'm going to do a third message. I'm just going to say thank you. And if I hit run again now, you'll see that it hasn't printed the third message. That's because it's waiting for user input. It doesn't matter what input it is. As soon as I do any input and hit enter, it will then say thank you. For the sake of making this more clear, we can say press enter to continue, and that means it's more obvious for the user what they need to do. And we just want that usability because it just makes our lives work better, as you can see once again. So when starting with any programming language, the first thing that we always try and teach is hello world, which is just making text appear on the screen. The tedious thing about learning to program is you need to practice doing things from the very beginning. There's not really an opportunity for us to skip ahead and get to the more interesting stuff until you've learned the basics. With that in mind, if this was a live class, I would normally take a moment to just copy what I've got on the screen and just get used to making your own version, recognize where things might go wrong, and then try again. The other thing that I would do is say, remember our keywords from earlier. I could even bring them up on the screen using comments. So I put each of these here. So at this point, if we stop, we'll hide the console, and I'll just be saying to my students, and you at home, if you're watching this, you can just pause the video, copy this into your own version of the editor, see that it runs, and then when you're done, have a think about these keywords that we've just covered, and I would like you to try and write down your own definitions for them. Rather than me telling you what they mean, try and think about how you interpret them based on how you're using them right now. So just a quick recap is the editor is the software we're using and where we're actually adding our text. This is our solution, the code. I said I wouldn't say what it means, but I'm just giving it a little bit. The console we covered a little bit as well. Subprograms are the pre-built code that we use in order to access we access pre-built code in order to do some functionality for us so that we don't have to do it ourselves. And we call them using the brackets, and then we say what exactly we want it to do using arguments. All right. I'm going to assume that you pause the video, and then I'm going to continue with part 2, if you're back. You may have encountered some problems. So with that in mind, I will first just going to copy this because this is going to come up as well. I think what I'll do is I'll copy this into a separate window so I have quick access to it later. We don't need to worry about that right now. So we started off with this basic print, input, print. If you made any mistakes, which the vast majority of people are going to do, you would have noticed that certain things come up. So I'll give you an example. I'm going to start by editing my code and adding print with a capital P. And I'll just put hello world. And I'm going to say run. And what happens is it just says trace back most recent call, blah, 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 blah. It basically says what I've just tried to do is not acceptable. Here it's actually warned me print is not defined. Because I've used these brackets, it knows I'm trying to call a subprogram. But it's case sensitive. You need to put exactly the right thing for it to work. So here, because I put capital P, it throws an error. So most of the time, it will try and tell you what the error is and where to look for it. So keep in mind, name error means you spelled something wrong. You might get a different type of error if, for example, I didn't put the speech marks at the end. You can see immediately it highlights as red. So if ever that happens, you know that there's something you need to do. But let's say somehow you've missed it. Here it says instead syntax error. So you can kind of ignore the exact phrasing, know that it's a syntax error, and it's something to do with a literal string. So here it actually gives you an arrow pointing to the exact point it thinks is the problem. It will not always know where the problem is. A very difficult part about being a programmer is debugging. It's finding these issues and understanding where you went wrong. Here, I demonstrated it quite easily. What I need to do that, and it will now run. So keep that in mind. If you encounter any errors, it will try and warn you. And just see if you can figure out where the error is based on either the phrase that it uses, or if it gives you a little arrow to say where you might have missed something. Chances are it might be spelling, or it might be that you've missed out on the correct syntax. Think of programming as a language, so this is like grammar. You need to make sure you put things in the right place for it to accept it. Also keep in mind, if you do copy and paste from other sources, it will sometimes copy the formatting and not work. It needs to be the format they accept. So there's different types of speech marks, for example. The wrong type won't work. It has to be this one. So it's better to type your code directly in than to try and copy it from another source that is not another application. Now, we've had a look at what we can do with our basic hello world, our basic printing. Now we want to talk about how we can use code in a more creative way. So the next step is variables. Think of a variable like a container. It holds information for you. So once we have a container, we want to assign that container information. So we use the equals to assign that information. And in this case, I'm going to use another string. I was going to call it Mr. Morrison, which is my teaching name. And you can just see that on its own doesn't mean much, but we currently have a variable. What I can then do is I can remove, let's update one of these ones that we're no longer using. And we're going to say hello. You can put a comma here. There's more than one way to do this, but for now we'll use a comma. And I'm going to put variable. The other thing I'm going to do is temporarily get rid of this, and then hit stop and run. And it just says hello, Mr. Morrison. So keep in mind, if I have put speech marks here, it would show variable because I've said print exactly what I've written. But if I don't put the speech marks, what it will do is it will look for something with that name. Here I declared variable and I assigned it the text Mr. Morrison, so that's exactly what it will print. You can combine it with other strings, which is something we call concatenation. So here we got hello, which is the literal string I put in. and then the variable which has the second part of the string, and it prints them together. If I wanted to add another variable, I could do something like second variable, and we could call that what did you do over the holidays as a question. Then I can say print second variable. If I hit run now, it's thrown an error. Now keep in mind, we talked about errors earlier. This one is saying it's a syntax error, meaning I put something that I shouldn't have. It's also putting an arrow next to the N and the D. And this is what we're talking about earlier when I said it won't always tell you what is the exact problem. It will only be able to give you an estimation of where to look. The issue here is it's seen the number 2, and it's seen that it's followed by a string or characters. This is not allowed in Python. It's not allowed in most software, most programming languages. Variables are not allowed to start with numbers. As soon as it sees a number, it assumes I'm trying to do something else. So the reason why it's not put an arrow under the number is because the number isn't what's wrong, it's what comes afterwards that's wrong. But from the perspective of the programmer, literally speaking, it's the number. So instead of second variable, I would put the word second variable. Now, if I hit run, I still get an error. Syntax error, invalid syntax. And this is because second variable still exists over here. When I try to call it, I'm calling the old name. So you need to remember, if you're going to update a variable name, update all of its instances. And now it works. So debugging, again, is really important. And once you start using variables and you need to understanding how we use them, you'll see that it's going to come up more often. Keep in mind, there's things that we call naming conventions, and it's the proper way to use variables and how to name them and to construct them. A variable is allowed to use and start with an underscore, but it's not allowed to have a space. So when we put variable names that are multiple words, we tend to separate them by using either A, snake casing, camel casing, which is when the first letter of the new word is capitalized, or B, we use snake casing. Sorry, again, my keyboard is weirdly assigned, where we separate the words using underscore. Again, if you do that, you need to update any instance of it. And this is not necessary, it's just best practice. It makes it more readable for a programmer, and therefore makes it more easy to edit and to debug if you're working on this later. This is a very small program. Once the program starts to get bigger, our need to get through information quickly becomes more important. That's also why variable and second variable are not great names, because we don't necessarily know at a glance which is which. Here I've said hello variable and then print second variable. If we came back and looked at this tomorrow, you would have to check what does variable mean and what does second variable mean. So instead I could say name and change this to name. And here I can call this one question. Now, no matter how much time passes, as soon as you look at this code, you know immediately what those things are. Naming things logically so that they support you and make it easier for you to identify them will save you a huge amount of headaches. With that in mind, we've just covered, we've taken a look at how we use our subprograms, and we can combine them with variables in order to print them directly, and how we use variables to store information. If we have a long variable like question, we can now use this multiple times, and I could, if there's no particular reason for it, put question, 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 and it will print that 3 times. The other thing to keep in mind is, and what I'll do is I'll just demonstrate it for the sake of it. You'll see that the question is repeated multiple times. So you can understand how storing a large string in a variable can save you a lot of time when you need to use that same string multiple times. Something like name I might use over and over and over again. So having it stored once makes my life easier. Also, if I want to update it, I only have to update it once, and every instance of name will update automatically. So variables are the lifeblood of programming. the better you understand them, the easier your life will be. This is how you manually assign a variable. That is, that you've done it yourself. But an important thing to keep in mind is that you can do it via another method too. So here I'm going to create a variable called answer. In Python, it will automatically create a variable as long as you haven't used the same name as a subprogram, and as long as you follow naming conventions. And all you have to do is assign it, and now it knows that's a variable. What that variable is will be determined by what you do next, but in this case, I'm going to use input subprogram, and then I'm going to say question, and now you'll see this time it asked the question twice because I kept the first print. So you can use input to ask to enter the variable name, the variable text that you want, and you can use print to do the same thing. The difference is now the program is waiting for me to do something. In this case, I'm going to type in my answer, and that will be programming. And nothing happens. So the reason nothing happens is because it's happening internally, but I haven't told the system to do anything different. So what I'll do is I'm actually going to take our print and I'm going to move it underneath answer. And instead of question, I'm going to change it to answer. So can you predict what will happen? We've got our name, we've got our question, what did you do over the holidays? I'm printing hello and then concatenating with name. I'm then assigning answer, the answer to our question, waiting for audience input or user input, and then I'm going to print the variable answer. So here, hello Mr. Morrison, what did you do over the holidays? I can type in programming, and then it returns programming, which is not that creative. So I can use concatenation again and say plus is an interesting activity. Now if I do it, programming is an interesting activity. And you can see how immediately you can start throwing together this. The way that a lot of AI and large language models work is they store information and then throw it back at you with like some predetermined text. Which is why a lot of automated emails and stuff like that work, is because they've just said variable plus the text that they always use, and that's why it can look personalized when it absolutely is not. Here you could even take this a step further and say name, I'll use the comma instead of the plus, answer, I haven't even thought about what that will say, and I'll say programming. Mr. Morrison, programming is an interesting activity. So it feels like it's responding to what I've said, it's responding to me as a person. So we've covered quite a bit already, and you can imagine this can get overwhelming fairly quickly, and this is why we want to take our time with it. At this point is where I recommend for students to, once again, if you're watching this at home, pause the video and then try and enter this on yourself. Keep in mind, programming is a lot about precision, meaning where I put name, I'm allowed to name that anything which follows the rules of naming conventions. I can't have a second variable called name equals Mr. Patel. Instead, I would need to do something like name2. Numbers are allowed as long as they're not at the beginning. Other than that, it's just a matter of keeping in mind that you're spelling things correctly, keep in mind that things are case sensitive, and how to debug and review what you might have done wrong. So try and enter this on your own debugger, or sorry, your own editor. Have a look and see how far you get with that. I would also recommend, what I'm going to do is I'm going to take that away, is enter in these new keywords and think about, is there anything here that you still don't understand, or is there anything here which we still need to add? One phrase I didn't cover was logic error. I did demonstrate it, which was essentially, like I said earlier, if I put name inside the string, then what will happen is the program will not recognize that I've made a mistake. It won't crash, it won't fail to run, it will simply keep going with the wrong information. Instead of hello Mr. Morrison, it says hello name. This is what we call a logic error. The system cannot recognize that it's not doing what you want it to do. Only a human looking at it can say that's not right. So we have to be careful with logic errors because they are the hardest to debug and they're the easiest to miss. Whereas if I put something like dname, it throws an immediate error, it refuses to run because I've made a syntax error. So syntax errors are the ones that will stop your program from running because you've entered something that the computer cannot accept and therefore cannot read, or cannot read and therefore cannot accept. Logic errors is when it can accept what you've put in, but you've still made a mistake and it's going to give you the wrong result. Otherwise, I think we've covered all of these terms. Hopefully, you are in a position where you can write them down, your own definitions, and you feel comfortable doing so. So, once again, I would recommend pausing the video, opening up your editor, and then trying to input this yourself. Assuming that you've done that, I just want to take a quick glance at the next step. So we're going to go away from the coding for a moment. We're near the end of this first video. I just want to go back to our slideshows. So in my lessons, I would normally talk about opening up our workbooks in which we have a series of activities that I would recommend trying to do. You, of course, watching this at home won't have this file to hand, but it's still a good idea. You can even Google this and think about these phrases and these kind of activities and whether or not you think you could do them. Could you print hello world? Do you understand what print is? Do you understand errors? Do you understand variables? And do you understand input? This is the activity that I'll be giving my students to participate in order to wrap the lesson up and just to see how far they get along. Inside our workbooks, they'll be expected to enter in the code from their solution into this field here, and then take a copy of the console to prove that they know that it's running. I would normally give these 7 instructions. So again, I have to stress, write your code in the Mu editor. You'd be surprised how many people will write it directly into a workbook or into a notebook or into a notepad or into Google Chrome or whatever. That's not ideal. If you're writing it anywhere other than in the editor and you make a mistake, you will not know you've made a mistake. And you will make mistakes. That programming is not even so much about learning how to do things right. It's learning what to do when things go wrong. Programming is all about problem solving. So it is a great activity to learn and practice for people who want to get better at critical thinking, problem solving, and respecting the fact that in life you will make mistakes. The mistake isn't the issue, it's what you do next that matters. Your ability to then move forward and correct those mistakes and fix the problems. That's why testing is a big part of our process. So I would then say, make sure that it is running. Don't just assume that it's working if you don't see anything immediately wrong. Hit play. You're going to be doing your debugging from a perspective of, does it crash? Are there syntax errors? We also do acceptance testing, which is when we're saying, does it do what we wanted it to do? Do we have a clear idea of what we were set up to do, and have we achieved that? You do that by checking the console. Then I would then say, this is for the students specifically, copy your solution into a workbook so that you have a copy of your work that you can refer back to, but also so that I can see that you've made progress when I review the work at the end of the session. There are practice examples where it's just write out different types of code. Only when you're doing the assessment examples would I expect a screenshot of your console to be placed there. So I emphasize that with the differences here at the bottom. And then tick off once you've completed each of those tasks. You submit Unit 1 to the classroom, and that way I'll be able to review the work and mark it. And then finally, update your keywords when you're finished with the Unit 1. A great reason why I want you to update the keywords at the end as well is we will be reviewing this. Usually I would ask the class like which keywords they're aware of and ask them a few comparative questions. Also, it's because some people do finish a bit earlier than others, so it just gives them something else to do while they're waiting for others to catch up. And questions to ask, things to research without them then jumping ahead to the next task. So I hope you found that interesting, especially, once again, I have to stress that this is my lesson plan where I'm going to be working with the students in class. I think it took me about 30 minutes to get through this. However, during an actual class, I would be taking gaps to let the students work through things on their own. That could be usually between 5 and 10 minutes for each activity, which means the entirety of the session goes on to about 50 minutes. with the option of a few extra tasks depending on how quickly people get through. So that's it's always good to have that bit extra at the end. If you like this video and you want to learn a little bit more about Python programming, I'm going to do another video, which is part 2, where we're going to delve into slightly more difficult topics, but it's still going to be beginner content. So if you like this, please like and subscribe. Let me know, give me feedback in the comments as to what you'd like to see more of, or anything that you thought I didn't do as clearly. Maybe I rushed a bit, maybe I wasn't clear with certain elements. I'm always open for feedback. The more I get help, the more I can help other people when I'm teaching. So thank you for that. And that should be the end of this clip.